Good morning, Andy. Welcome to Power Electronics. Next video.
Here, this is the structure of power diode. It consists of heavily doped N plus substrate. Okay, you can see here N plus substrate, heavily doped N plus substrate. What is meant by this substrate? Okay, what is meant by this substrate means a material on which something grows is called substrate. On the substrate, a lightly doped N minus layer will be grown. N minus layer will be grown. Now, a heavily doped P plus layer. A heavily doped P plus layer is there na? A heavily doped P plus layer can be diffused into N minus layer to form the anode of the power diode. That means the function of the N minus layer, here the function of the N minus layer is to absorb the depletion layer of the reverse biased P plus N minus junction J1. That means the breakdown voltage needed in a power diode governs the thickness of the N minus layer. The drawback of the N minus layer is to add significant ohmic resistance to the diode. Once again I am repeating. Simply it consists of a heavily doped N plus substrate. On the substrate a lightly doped N minus layer will be grown. A heavily doped P plus layer is diffused into N minus layer to form the anode of the power diode. This shows that N minus layer is the basic structural feature not found in signal diode. That means this N minus will not be there in signal diodes. The function of the N minus layer is to absorb the depletion layer of the reverse biased P plus N minus junction J1. The breakdown voltage needed in power diode governs the thickness of the N minus layer. Okay, that is the basic structure of the power diode. This is the symbol which is consisting of one anode and cathode, and of course VD is the diode voltage you can see. Next, coming to characteristics, there will be of the two types of characteristics will be the of the power diode, just like our normal diode. Here first one is forward characteristics of power diode, and the next one is reverse recovery characteristics of the power diode. In order to get forward characteristics, when the anode is positive with respect to the cathode, diode is said to be forward biased. Once again I am repeating, when the anode is positive with respect to the cathode, diode is said to be forward biased. With the increase in the source voltage from zero value, initially diode current is 0. From Vs is equal to 0 to the cut-in voltage, the forward characteristics will be diode current is very small. Here you can observe that for cut-in voltage, and here cut-in voltage is also known as the threshold voltage or turn-on voltage. Cut-in voltage can also be called as the threshold voltage or turn-on voltage. Beyond this cut-in voltage, the diode current rises rapidly. Okay, diode current rises rapidly, and a diode is said to be conductive. For silicon diode, cut-in voltage is nothing but 0.7 volts. When the diode conducts, there is a forward voltage drop of the order of 0.8 to 1 volt. For low power diodes, the forward current grows almost linearly with the voltage, and high magnitude of the current in a power diode leads to ohmic drops. These are the explanation for the characteristics of the power diode. And next one, this is the ideal characteristics. Here one more point you can observe, V or M. Okay, VRRM means here peak reverse repetitive voltage. A large reverse breakdown voltage associated with the high reverse current leads to excessive power loss that may destroy the diode. So that's why the reverse breakdown of the power diode must be avoided by operating it below the VRRM. VRRM means peak reverse repetitive voltage. That means we need to operate our diode under the VRRM only. We need to operate. If you go beyond this one, large breakdown voltage, then what will happen? High reverse current will be there, leads to high power loss will be there. Okay, so that's why this may lead to what will happen? Destroy the diode. And it is just like our peak inverse voltage. Peak inverse voltage is same as the VRRM. These are the VA characteristics of the power diode. Here for the case of the reverse recovery characteristics, after the forward diode current becomes zero, the diode continues to conduct in the reverse direction. Okay, continues to conduct in the reverse direction because of the presence of the stored charges in the depletion region and the semiconductor layers. The reverse current flows for a time is called reverse recovery time. This time can be called as the TRR, reverse recovery time. And the diode regains its blocking capability until the reverse recovery current decays to zero. That means here the reverse recovery time can be defined as the time between the instant the forward diode current becomes zero and the instant the reverse recovery current decays to 25% of the reverse peak value. This is the IRM, reverse peak value. Up to 25% means 1 by 4 of the IRM. And next here TRR is equal to TA plus TB. Here you can observe that reverse recovery time is equal to TRR is equal to TA plus TB, where in the TA the charge stored in the depletion layer has been removed, and in the TB it will reach 0.25 of the IRM. Here the ratio of the TB to the TA. Here the ratio of the TB to the TA can be called as softness factor. This factor is a measure of the voltage transients. Okay, measure of the voltage transients that occur during the time diode recovers. Whenever it is recovering now, then the transients will be occurred, that will be measured by the softness factor. If it is usual value is 1, the softness factor value, usual value is 1, and it indicates low oscillatory reverse recovery process. If the softness factor S factor is small, diode has large over voltage. If the softness factor is small, okay, if the softness factor is small, then diode has large over voltage. If S factor, okay, if S factor is equal to 1, then it can be called as the soft recovery diode. If the S factor is less than 1, then it can be called as the snappy recovery diode. Okay, snappy recovery diode is nothing but fast recovery diode. Please remember that. A snappy recovery diode can also be called as a fast recovery diode. What is meant by S factor? S factor means simply ratio of the TB to the TA. What is meant by TB? TB is the time taken for the current to reach 1/4 of the IRM. What is meant by TA? The current instant from the current is going from 0 to the IRM